Hi guys. So last week we discussed linear equations and we talked about how to calculate or find the equation of a line given some points and a slope, and we also talked about graphing those lines. So today we're going to now start looking at two equations and their relationship with each other. So when you have two equations, it's called a system of equations. So a system of equations is a collection of equations in the same variable. So if you take a look at this example I have right here, we have 2x minus 5y equals negative 3 and negative x plus 2y equals 3. So it's two equations, they both have x's, they both have y's, so they have the same variables. When you're dealing with systems of equations, the answer, the solution, is going to be a point that satisfies both of the equations. This point will be an ordered pair. So we're first going to take a look at some equations that are already graphed for us. Slide this over a little bit. So if we have these equations that are already graphed for us, we have systems that can form intersecting lines, coinciding lines, or parallel lines. So we're going to look at, let me grab my pen here. We're going to look at this graph first. So if you take a look at this graph, these two lines are clearly intersecting. So the point where they're intersecting is going to be our solution point. So the two lines are going to meet right about here. So if this is the point where the two lines meet, then that ordered pair is going to be our solution. So what is that ordered pair? Well, my x is 1 and my y is 2. So that means that our ordered pair, or our solution, is 1, 2. So when you have two lines that are intersecting, they're only going to have one solution. Now, let's take a look at these two lines over here. These two lines are considered to be parallel lines. Remember, parallel lines have the same slope. So if these two lines are parallel lines, are they ever going to intersect? Hopefully, you're saying to yourself, no. So if they're never going to intersect, then this is what we call a no solution. Remember, we talked about those special cases before when we were dealing with solving equations. So this is the same kind of thing. All right, last one. We have coinciding lines. So if you look at the graph of it, it's going to look like there's only one line on our page. But really, I did graph two lines, but the two lines happened to be one on top of the other. So when you have coinciding lines, that means that there are infinitely many solutions. Infinitely many. So we have three types of solutions here. We're going to have one solution, no solution, and infinitely many. Okay, so now let's take a look at steps for solving a linear equation by using the graphing method. Using the graphing method, you first need to make sure that your equations are written in slope-intercept form, because remember, you can't graph equations unless they're written in slope-intercept, because you need to know your m and your b. Next, we're going to actually graph those two lines, but make sure that those two lines are on the same coordinate plane. And lastly, we're going to try and find that point of intersection, if there is one. There are three methods to solving. This one is just going to be the first one that we look at. There's graphing, substitution, and elimination. So we're going to start with some graphing examples here. Okay, take a look at the two equations. Are these two equations already in slope-intercept form? Yes, they are. So what we want to do now is we want to go ahead and, sorry, I went a little too far. We want to go ahead and graph those lines. So let's take line 1, and I'm going to graph line 1, which is up at 4, and it has a -1 slope. So remember, if your slope is a -1, that really means -1/1. And remember, only one of them is negative. You either want to go down 1 to the right 1, or you can make the denominator negative and go up 1 and back 1. Either way, this is your, sorry, let me just plot some more points. This is going to be your equation. Here's some other points, and hopefully I can do this relatively, sorry. Make sure that you guys use a ruler when you're doing this on your paper. Now let's take a look at that second equation. So let's grab a different color here. Second equation, we have y equals -2x plus 5. So we're going to go up to 5, and this time we have a -2 as my slope. So again, if it's a negative 2, it's really over 1. So I can go down 2 to the right 1, or I can go up 2 and back 1. So this one actually worked out really nicely. Oh, sorry, my lines are not straight. This one worked out really nicely because where the two intersect, you can clearly see, you graphed over it. So this point right here is where the two lines intersected. So what is the solution to these system of equations? Take a look at what is the ordered pair there. The ordered pair is 1, 3. Okay. Let's take a look at another one. Okay, these two lines are not actually in slope-intercept form, so we need to take some steps to start off our problem before we can graph. So we have x plus y equals a negative 2. So I'm going to subtract x from both sides, so y equals negative x minus 2. Let's take a look at the second one here. 2x minus 3y equals negative 9. So subtract your 2x from both sides. Don't forget that that y is a negative 3y. And then we're going to divide all terms by a negative 3. And when these cancel, you're left with y equals a positive 2/3 x plus 3. Okay, so now let's go ahead and graph those. I'm going to graph my first equation. Change my pen color. My first equation in green. So I'm going down to negative 2. And I have a negative 1 slope. So again, down 1 to the right 1, or up 1 and back 1. Oh, sorry. And graph that line there. Oh goodness, I'm sorry, I'm so bad at this graphing on the computer here. Should be going like this. There we go. And now let's graph our second line. I'm going to make that blue, and we're going to go up to 3. And we have a 2/3 slope, so we're going to go up 2 and over 3. Or if you wanted to find a point down in this region, because remember this is where our line is, we can always go down 2 and back 3. So if I do that, it's a lot more clear what that actual solution is going to be. So my solution is going to be this intersection right here. So we have to write that point as an ordered pair. So I have negative 3 and 1 as my ordered pair. Okay, so I think you guys kind of have the general gist. This is really nothing new because we've already looked at changing equations in the slope-intercept form, and we've already looked at graphing lines. So now all you have to do is take it a step further and find the solution. What I would like to see you do is graph these two and tell me, do they have an intersection? So is there a solution? And if there is, what is that solution? So here's one example that I would like you to do. Is there a solution, and what is it? And try this one as well. Is there a solution, and what is it? When you're finished going over this video, if you have any further questions, you can watch it again. If you are clear and good to go, then I would like you to complete the worksheet that was given to you in addition to the note sheet. Okay? See you tomorrow.